Welcome back to the channel. Today we'll be doing lead course 704 binary search. Binary search, this is both an algorithm and a lead code problem. Binary search is used to find a number in a sorted list or an array. So let's begin this question without any further delay. So here's the question. Given an array integer nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return 1. So it is basically asking you to write and binary search algorithm. Binary search is an efficient algorithm for finding an item from a sorted list of items. It works by repeatedly dividing in half the portion of the list that could contain the item until you have narrowed down the possible location to just one. So in this, let's see as an example, in this array the target is 9. Okay, so if we writing the so if we narrow down the array into half, so let's see. So this is an this this basically is into left half and right half. So if we narrow down into half, so let's take the um, since it is an even number of element, let's take this as an mid. Okay, so let's take this as a mid. So we 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 have divided the list into half. So what we usually do is, since it is an sorted list, there is, and we compare the mid value and the target. There is no chance that the element 9 will be found in a lesser half, which means the since the target is greater than the mid value, there is no chance that target will be in this area, so we cross this. So what we do is we have divided the array. Now we check into this area. Now our left will be this and our right will be this. Okay, so we again find a mid value. This is the mid value. We compare, we find it, we return it. Okay, so that's how we find an element using a binary search. So let's look into another example. This example was quite short and we easily found it. So let's do an example where we do not find it. So the second example, we do not find it. Okay, so in this example, this will be the left, this will be the right, since it also has like even number of elements. So let's take this as a mid value. Okay, so let's take this in a mid value, which so our target is okay, what is our target? Our target is 2. So 2 is less than 3, so we do not check in this area, we check in this area. So now we shift our right, this is our left. The left will be, since there is only 2 elements, our left will be the mid as well. So left with a will be the mid. So this will look like this, left plus mid, and this will be our right. Our target is 2, so we check, compare between target and mid value. So the mid value is less than the target, so we move our mid pointer with so we move our left value to 0. So our left is also this, our right is also this, our mid value is also this. So it is still not equal, and we have reached into a condition that left is greater or equal to right. So now we cannot, like, there is nothing that we can move into. We cannot move our left beyond the right. So this should be our condition. Okay, we we reached into left equals to right, not equals to right. So usually when we are using two pointer, we do not pass the left pointer away from the right pointer, which means that left pointer and the right pointer, left pointer should always be on the left side of the right pointer. We do not put like right pointer and then left pointer. We do not do that. We usually have the condition left is less than or equal to right. We can have it on the same pointer, but we do not usually do that. So we do not find here. So we have already checked the possibility and we do not find, we return -1. Okay, so this is the algorithm of how binary search works. So let's write into this code to have further understanding. We are with the coding session. So write the algorithm. Binary search is a left pointer and a right pointer, right pointers, right pointers, mid pointer on the mid and array. If so, what happens is if left pointer with the mid pointer is either what would either left equals to mid +1 or right equals to mid -1 or return. So this is basically so what this means is either we find it on the left side or the right side, and then we divide the portion of the list, or we have already found the list. We have already found the element in the list, so we have already seen how we can divide it. So this is just a small version of an algorithm. So let's write in the code. Left equals to 0, right equals to len norms -1, then write the while condition while left is less than equal to r, then let's do an integer division, find a midpoint if target equals to nums mid. We return the index. So okay, elif target is greater than nums mid, return. No, we don't return, we move the pointer. Now if target is greater than nums, then we return the left pointer mid. Okay, else we turn the right pointer. So this usually means is target is greater than mid, so it means that we do not have it on the left portion. The left side, what we have divided into left and right, it means that target is already greater than the mid value, so there is no reason to check it on the left side. We can move the left pointer to the mid value and try to break down the right portion. So that's what it means. So if we do not find, the question says return -1. Okay, let's run to check any syntax errors. Okay, it got accepted. Let's submit it. Okay, so it got accepted. So another question. So it says that you must write an algorithm with O log n. So since we have repeatedly divided in the half the portion of the list, like we have already seen here how we did it, and we have also seen in the mm, like sketch. So this will be the O log of n runtime complexity. So we are doing it like correctly of how the question is asking. So yeah, this is the video, guys. If you like the video, just leave a like. If you have another way of how we can solve this problem or new ideas, feel free to comment down. And if you like the content of the channel, feel free to subscribe. We upload more videos on data structure and lead code problems. This question falls under both lead code and data structure problem. So yeah, feel free to join our journey. This is for educational purpose. I am creating these videos so that I have a better understanding of different data structures. So comment down if you have any new ideas. Yeah, thank you guys.